So my talk today is about modern security mechanisms and which challenges they bring in terms of open source firmware. And
just a heads up.
so just a little bit about me.
I'm currently
I'm
doing
an
something for my
open
parents,
source
giving me
enthusiast.
books. So
I spend way too much time on open source projects. I'm mostly working on coreboot and things around it. But I'm also a little bit involved into NixOS and Arch Linux. Specifically, so for example, I'm packaging the coreboot toolchain for those two distros. So why this talk? I started to think about which barriers beginners or interested people might have, and how we can simplify their start into this field. And so some barriers are mentioned here. It's, for example, closed source binaries, which are necessary for the platform initialization. They are a black box, and people are scared of them. People don't know how to debug them or to solve issues. So it's just very hard to deal with them. Another issue is that lots of documentation is not available. So it's just available under NDA. And another issue which this talk is about is the firmware validation, which in case of Intel and AMD is BootGuard or the PSB, the Platform Secure Boot. The good thing about firmware validation is that it's a security feature, so it's good because it prevents bad people or attackers to modify the system's firmware to do bad things and such. But it also comes with a downside because it prevents users to use their own firmware. And so it also has a negative impact on sustainability. And so the problem is vendors. It doesn't matter who of them, Lenovo, Asus, and so on. The vendors don't document on which hardware they enable their firmware validation. I don't know much about I don't know much about how AMD works or how it works for AMD because there are not many things public available. So this talk is mostly about Intel BootGuard. Just to give a little overview how things. Well, it's a very small overview, but just to give a little overview about how things are implemented. In case of BootGuard, it comes with the management engine, and the management engine resides in the chipset. So in case of low power platforms, it's one sock, so it's one chip which is soldered on the mainboard, but with on desktop platforms, they are separated. So when you put the CPU in case of the firmware validation is enabled and you put the CPU onto another mainboard, the CPU still works, which is not the case for AMD because the platform secure boot comes with the PSP, and so PSP is the equivalent of the management engine, and the PSP resides in the CPU package. So when a vendor enables the firmware validation, the platform secure boot, then and sets diffusers, then it's impossible to reuse this CPU on another mainboard because the signature does not work on this one. So back to the open source developers. When we want to figure out which mainboards are locked down and which are not, which possibilities do we have? The easiest one is also maybe not for everyone, not for every person, but for a beginner, the easiest solution is also the hardest one, because buying the mainboard and then modifying the firmware and trying it out, and it's kind of hard. Or another possibility is using UFI tool. UFI tool recognizes signatures of BootGuard and gives some hints if BootGuard is enabled or not. But even then, it might be possible to boot another firmware even then, because BootGuard can run in different profiles. So, for example, the vendor may enable BootGuard, but the mainboard may still boot. That's one of the profiles. Another profile is that BootGuard is just enforced, and the user can't do anything. Another possibility to check is the Intel ME tool, or reading the registers manually, but also that is it might be kind of overwhelming for beginners, or for beginners, and so it's also not a proper solution. We also could use hardware vendor tools, but so in case for Intel, for example, they have some tools where you can open the where you can open the firmware image, and then you can just see which BootGuard profile is enabled, and yeah. But it doesn't tell you if the fuses are set. At least in my understanding, it doesn't tell you that. And I think it also doesn't tell you if the management engine manufacturing mode is enabled or not. And I think in case of that, you can just disable BootGuard and run your own firmware. So my idea is a collective approach. I just called it BootGuard status. I started it some years ago, and it's basically just a markdown table listing different vendors and their mainboards, and yeah, and the idea is that people who found out the state, the BootGuard state of their mainboard, just document that, and yeah, and so it just gives an overview, and whoever is interested can look at this list, and they can just pick a mainboard they want to work on. And yeah, and people who are not that deep into this field or into this topic, they don't need to be afraid of buying something locked down. And yeah, so that's basically the idea. And yeah, that's it.
Yeah, I guess there are questions like Hannes said.
So, hang on, how to phrase this. So sometimes when I'm looking for information on a particular board,
I can't hear Hannes.
You cannot hear me.
Yeah, so I hear him. So Felix, rather the problem is on your side. Can you try to just re-enter the session?
Yeah,
and sure.
Just I can just type it real quick.
But it still will be problem. Like just reload the page, Felix. Just reload the page, and I guess you will get it. Yeah, let's try it, Felix. You're muted, by the way.
Okay.
Can you hear me? Can you hear me?
I still can't hear Hannes.
Oh, okay. So maybe that's Hannes. Like that's the other option.
Wait, I will restart Chromium. Wait a second.
No. It's Felix.
How about now?
I don't know. Felix decided that this is his problem, so he restarted the Chromium.
Okay.
Can you hear me now?
Yes.
Okay.
Yeah. So sometimes I want to look up some information on a particular board. I'll go to I forget the exact name of the website, but it's like linuxhardware.org or whatever, and it's it's just basically the same kind of idea as what you got here with BootGuard status, a collective approach. Do you think it might be worthwhile, because like a lot of people will just run this information on their hardware, even though they might not be interested in coreboot per se, to maybe talk with those guys to see if they can incorporate the tools that might be able to tell that, and then that way we get passive collection regardless?
Sorry, I'm not sure if I.
Yeah, I'm not sure. I'm also not.
Okay. So there's there's a tool. It's basically like it's an app image. It's a whatever. They got it in a million different forms, and it runs, LSPCI, DMI decode, sensors detect, all those goody hardware detection stuff, right? And it takes all that information, anonymizes it if need be, MAC addresses, IP addresses, things of that nature, and uploads it to an online database where you can query the database for a particular piece of hardware, and then look at that piece of hardware and see what's, whatever Linux can report. Do you think maybe it might be worthwhile to speak to the people who run that project, like, hey, I would really love it if you added this particular form of detection into it. That way, people who are running this tool for other reasons are passively collecting the BootGuard status of their devices. Ask them to run Intel ME tool as part of their probe.
Yeah, sure. I didn't know the project before, so linuxhardware.org.
Cool. Yeah.
No, it's not.
They got an app, and it, like I said, it runs LSPCI, DMI decode, yada, and collects all that information, anonymizes it, and uploads it. So it's got all kinds of information on all kinds of hardware there.
Yeah, sure. I think that would make sense. That would be great. I actually.
You hear me right now?
Yeah.
Yes.
Yeah, you didn't heard me before. So we were in contact with Linux hardware when he noticed the Dasharo reporting in the BIOS section, and of course the database can be extended to that, but we have to work with such big. And on the other side, the question is if there is any limit on running those applications which gather this information, because you have to provide certain specific conditions, and I guess like Linux by default not booting giving the so much access that you can check the registers.
You're talking about like IO memory LX and such?
Yes.
It would be, well, even if that is the case, maybe Linux hardware people could, provide a caveat when they use the application, like, hey, this works better if you boot with this enabled.
Mm-hmm.
But
Hanetzer, that's why we're doing DTS, the Dasharo tool suite, and we kind of because we have custom baked kernel with of course some protection disabled because of the because we have to access this information, this information which is normally in every distro locket. So ideally would be if we can ask people. I understand your point. It would be easier if we can passively gather this information, but it's not that easy, and would be harder and harder, in my opinion.
Okay, it's just an idea.
Yeah. So better would be like this. Like better. I don't know if it's better. It's not better because it will not gather so much results as you're saying. But the situation in which someone asking the question, like asking. Is my hardware capable of being ported? And then like we're just saying like just run this, and like it magically will tell you. Because right now the problem is, Felix tried to describe this, but on the slide that the analysis of the output is too complex. So yeah, you're getting ME status register, you're getting the BootGuard status register, and so on and so on, and what if you don't know how to interpret those numbers, then this doesn't tell you anything. And I wanted to bring Michał here, Michik. I don't know if he listen.
Yeah, I'm listening.
Yeah, so I'm just saying like the problem is not about. It's not about, we cannot gather this information. We can gather this information. There are tools for that, but the point is to represent that in a human readable way, and Felix trying to achieve that with the GitHub page where he essentially gathered this information. But the point, Felix, is exactly, I guess the problem is exactly the same like with HCL. So we gather this information, or this gathering this information is too complex. But Michał, tell me about one thing, the statuses of the registers, how hard it is to interpret that. How hard is the logic diagram of interpret that?
For the BootGuard, well, essentially, we have to consider only two cases. Before
Felix, are you attempting to talk?
should I
Felix?
continue?
Felix, are you attempting to talk or?
No,
Okay,
no,
okay.
sorry. Go ahead. I actually don't know that much about the BootGuard registers yet, and
Yeah. So what I wanted to say is that we just need to consider two cases. Before convert BootGuard and TXT was introduced, and after, because this is where the registers got a little bit
Like I want to figure
changed.
out like.
But yeah,
Hanetzer, do
this
you
is just
hear Michik?
No, I do not hear.
Oh damn,
Okay.
damn. So Michik's talking and you don't hear him.
No,
that's
I
great.
hear nothing but me and you right now.
Okay.
All right, that's also fine.
What to do with that? I don't know what to do with that. So we can try this experiment with this instance that Maciej pointed to, this Galena. It seemed to work. This is NLNet. I don't know if you know NLNet. This is NLNet instance. So those who know NLNet is like they are a very trustworthy group of open source sponsors in Europe, in Netherlands. And maybe we will solve like problem for our small group.
yeah, that would be awesome.
Yeah, let's try that. Let's try that, and we will see.